Concrete is a composite material consisting of an aggregate bonded together with a glue-like substance called cement. Admixtures are often added to the concrete mix to achieve desired properties or modifications of the concrete. In the construction industry, concrete is the most commonly used material due to its durability, resistance, and long service life. There are many causes of concrete degradation, including the carbon steel reinforcements being exposed to corrosion. Chemical damage, such as sulfate attack, carbonation, chlorides, and leaching, all contribute to the reduction in strength of concrete members. Thermal damage occurs when concrete is exposed to unusually high temperatures, which cause the concrete to lose its strength and stiffness. Aggregate expansion happens when chemical reactions such as the alkali-silica reaction occur inside the concrete. Direct physical damage is most commonly caused by abrasion and erosion of the concrete. Continuous contact with moving or still water slowly deteriorates and erodes the concrete.
Water leaks are a critical factor to the deterioration of concrete due to its porous nature. Water can also play a role in the corrosion of reinforcing steel, leading to the decrease in bond strength between concrete and steel. Water can flow through porosities and cracks in the concrete and can travel through gaps formed from drying shrinkages. Waterproofing methods should be used in projects associated with water, for example, water treatment plants, bathrooms, roofs, basements, and structures surrounded by water. There are two main methods used to block cracks in concrete, the first being crack injection method. Different fluids could be injected using this method, although to stop water from leaking through these cracks, polyurethane foams need to be used. This foam expands almost 10 times its size when it reacts with water, and blocks any more water flowing through the crack. Although polyurethane crack injection method is reliable to block water from leaking, the punching of injection pins in the concrete weakens the structure. Therefore, the hose injection system is a good alternative to implement before the pouring of concrete. The hose injection system is simply a number of hoses placed between reinforcing steel, all connected to a tap used to inject the fluids.
Factors that play a large role in deciding the method of repair include material properties, ease of application, cost, the environment, and available skill and equipment. One of the most common and highly versatile materials used when repairing concrete is mortar. In specific ratios, mortar can achieve desired properties in both the plastic and hardened state for a wide spread of unique repair applications. They range from superficial patchwork, cracks, and coverings to structural elements. There are three main types of mortar: standard Portland cement mortar, polymer modified mortar, and epoxy-based mortar. The design of the mortar's properties largely relies on the existing concrete. In most repair applications, the mortar is needed to perform monolithically with the existing concrete structure. When there is a significant difference in the properties of the new material and existing substrate, forces can focus and exert mainly on the bonding plane, causing separation and an accelerated deterioration of the repair. There are a large number of methods to apply mortar for a repair, which include by hand with a trowel, pumped and confined by formwork, injected, and gunting among others. A local example of polymer-modified mortar being used is the repair of Fairy Creek Bridge in Fairy Meadow, Wollongong. It had corrosion damage to the reinforcement from the spalling and cracking of the concrete cover. This repair method consisted of the removal of the concrete up to 25 mm behind the steel reinforcement, which was achieved by hydro-demolition. It produced a good service for the bonding of the new mortar.
The rehabilitation method of jacketing consists of encasing the existing damaged structural concrete member with a steel reinforcement cage, and then cast-in-place concrete or shotcrete is used to construct the jacket. The first step to jacketing is to prepare the existing surface, making sure it is ready for a new concrete to be bonded to it. Chemical cleaning and acid etching are sometimes used for this, but most commonly abrasive preparation is used. When it comes to the design of jacketing as a repair method, the combined action of the old and new concrete must be considered. In some situations, the jacket can be designed to carry the entire load. These design parameters of the new jacket are to be designed to the suitability of each individual case based on the structural architectural details.
FRP is a composite material of a polymeric resin acting as a matrix reinforced by strong, stiff fibers. Carbon fiber reinforced polymer, CRP, is an FRP fabricated from carbon fibers. Standards Australia Handbook 305 2008 is essential when looking at using FRP for the repair and rehabilitation of reinforced concrete structures. There are two main methods of applying FRP. FRP is typically used for flexural support, shear support, column confinement, or lateral support, impact resistance, as
When built properly, concrete roads will only need to be rehabilitated every 10 years or so. However, a highly controlled and good quality repair is required. It is essential that any faults in reinforced concrete pavement are rehabilitated straight away to prevent further damage to the pavement, which can be irreparable. Type A repairs involve the rehabilitation of any joints or cracks in the pavement by sealing these with joint sealant. When sealants are damaged, chemicals, solid materials and water can get into the reinforcement system, causing huge problems down the track. These repairs need to occur straight away. Type B repairs are utilised for small-scale surface damage in the pavement, such as scaling, spalling, map cracking, deteriorated partial depth cracking, decracking and shattered slab. The steps include marking and hammering out all deteriorated concrete, preparing the area with formwork, replacing and curing the concrete, and finally, sealing any cracks or joints. Type C repairs involve the replacement of transverse contraction joints. They are used when a small portion of a whole pavement is damaged and needs to be replaced. The first step is the removal of the existing joints. Next, the pavement is sawed full depth on both sides of the repair and along any tied lane. The area is prepared for the concrete replacement and the new concrete is placed and finished. Finally, any cracks or joints are sealed. Finally, Type D repairs are used when a large volume of a reinforced concrete slab is damaged. The minimum dimensions of this area is usually 3 metres long by 1 lane width wide. The pavement is sawed at full depth on both sides of the repair and along any tied lane. The concrete is then removed from the repair area. The area is prepared for the concrete replacement and the new concrete is placed and finished. Finally, any cracks or joints are sealed.